A triangle has three sides. Let's quickly sketch a triangle over here. To name a triangle, we name each vertex using a capital letter. So let's call this triangle A, B, C. The angles inside the shape are known as interior angles. So let's draw an interior angle inside A, inside B, and inside C. Now, there are three ways to name an angle. First, we can name it by the sides that created it. To create the angle at vertex A, we go from B to A and then to C. So we can call this angle up here BAC. Let's make our triangle blue again. Using this idea, we can call the angle at B ABC, and we can call the angle at vertex C ACB. Remember to always put a cap that looks like an arrowhead on the middle letter to show that this is an angle. Another way to name an angle is by the vertex it sits inside. So inside vertex A, we have angle A. Inside vertex B, we have angle B. And inside vertex C, we have angle C. We usually use these two ways when writing equations or making statements about the angles. The third way is to use lowercase letters, and we can write these angles inside the curve on the diagram. So here we have angle A, angle B, and angle C. The sum of the interior angles of any triangle is always 180 degrees. So if we add angle A, angle B, and angle C together, we will always get 180 degrees. Next, let's look at the sides of the triangle. There are two ways we can name the sides of a triangle. The first way is by the vertices the side lies between. This side lies between vertex A and vertex B, so we call this side AB. The side at the bottom lies between B and C, so we call this side BC. And finally, the third side lies between A and C, so we call this side AC. Another way is to name the side by the vertex that lies directly opposite it. We call the side directly opposite angle A, lowercase a. We call the side directly opposite vertex B, lowercase b. And we call the side directly opposite angle C, lowercase c. Triangles are classified by the lengths of their sides, and there are three types of triangles we need to consider. There are equilateral triangles, isosceles triangles, and scalene triangles. Let's start with equilateral triangles. Let's draw in a triangle and call it ABC. An equilateral triangle has three equal sides. In geometry, we use a small line like this to show equal sides. Here, side AB, side AC, and side BC are all the same length. An equilateral triangle also has three equal interior angles. So angle A is equal to angle B, which is equal to angle C. We know that the sum of the interior angles of a triangle is 180 degrees. And if all three interior angles are equal, then 180 degrees divided by 3 gives us 60 degrees. This means that every angle inside an equilateral triangle is 60 degrees. So we can fill these in to our diagram over here. Next, I'd like to look at isosceles triangles. Let's draw a quick sketch. An isosceles triangle has two equal sides. So in this case, let's say that AB is the same length as AC. An isosceles triangle also has two equal angles. The equal angles lie directly opposite the equal sides. So in this case, angle C lies directly opposite side AB, and angle B lies directly opposite side AC, which means that these two angles will be equal. Let's tidy this up. Now we know that we draw a curve to show an angle, and in our previous videos we've used different colors to show the certain sizes of different angles. But in an exam situation, this is not as easy. An easier way to do it is to draw more than one curve around equal angles. Let's draw a blue curve for angle A. Now we have just said that angle B is the same size as angle C. So let's draw two curves at angle B and two curves at angle C. Now we can see in the diagram that angle B is the same size as angle C, but angle A is not equal to either of these angles. Next, let's look at scalene triangles. Let's draw a quick sketch. A scalene triangle has three unequal sides and three unequal interior angles. We have said there are three types of triangles when we classify them by the lengths of their sides, but there are actually four types of triangles when we classify them by their angles. So the last triangle we need to look at is the right-angled triangle. From our previous video, we know that a 90-degree angle is also known as a right angle. So this is a right angle triangle, and this is also a right angle triangle. We call it a right angle triangle because it has one interior angle that is 90 degrees. Now, an equilateral triangle will never be a right angle triangle because an equilateral triangle only has interior angles of 60 degrees. So a right angle triangle can only be isosceles or scalene. In the triangle on the left, let's say that side AB is equal to side AC. So this is a right angle triangle. It is also an isosceles triangle because two sides are equal. So this is a right-angled isosceles triangle. In the triangle on the right, the lengths of all three sides are different. So this may be a right-angled triangle, but it's also a scalene triangle. So this is a right-angled scalene triangle. Next, I'd like to look at exterior angles of a triangle. Let's draw a quick triangle and name it ABC. We don't know if this triangle is equilateral, isosceles, or scalene. The sides do not matter. Here we are focusing on angles. We know that an interior angle sits inside the triangle. So let's draw an interior angle at C in blue. So where is the exterior angle? Well, many students assume that if the angle inside the triangle is the interior angle, then the exterior angle must be outside the triangle, and they look at this whole angle over here. But this is the most common error. So let's take this purple angle away. In mathematics, you will see equations or examples that state how a line is extended. The word extend means to make longer. So as an example, let's extend line BC and name this end of the line D. The exterior angle is smaller than 180 degrees and lies between the extended line and the adjacent side of the triangle. Remember that adjacent means next to, so this is our exterior angle. For the sake of example, let's extend line AB to E and extend AC to F. At B, the exterior angle lies between the extended line BE and the adjacent side BC, so our exterior angle lies over here. At A, the exterior angle lies between the extended line AF and the adjacent side AB, so our angle sits over here. Let's tidy our diagram up a bit so we can focus on one exterior angle. Let's call this angle D. Now let's quickly name our interior angles. Let's say we have angle A, angle B, and angle C. We know the sum of the interior angles of a triangle is always 180 degrees. So in this case, angle A plus angle B plus angle C is equal to 180 degrees. We also know from our previous videos that the angle of a straight line is equal to 180 degrees. Here, C and D lie on a straight line, so we can see that C plus D is also equal to 180 degrees. Now we have two equations that are both equal to 180 degrees. And in algebra, we learned that if two equations are equal to the same value, then the equations themselves are equal as well. So we can see that A plus B plus C is equal to C plus D. We have a C on both sides, so these will cancel out. And on the left, we have A plus B, which is now equal to D. This means that the exterior angle of a triangle, which in this case is D, is equal to the sum of the opposite interior angles, which in this case are A plus B. Please make sure to learn this rule as you will use it throughout geometry. Now, I'd like to look at some examples of how we work with triangles. Calculate the unknown variables in the following figure. Now, in this case, we know that the sum of the interior angles of a triangle is 180 degrees. So we have x, y, and an angle of 36. So we can say x plus y plus 36 degrees is equal to 180 degrees. In the triangle, we can see that side AB is equal to side BC because of these two small lines. So we are working with an isosceles triangle. We know that an isosceles triangle has two equal sides and two equal angles. X lies directly across from BC and Y lies directly across from AB. So X and Y must be equal. So let's tidy this up and we can make a note of this up here. X is equal to Y. So now our equation becomes X plus Y, which is equal to X. So let's say plus X plus 36, which is equal to 180 degrees. And now we can solve for X. So let's add our like terms. X plus X gives us 2X plus 36 degrees is equal to 180 degrees. Now to get the X term by itself, let's move 36 to the other side. On the left, we now have 2X, which is equal to 180 degrees minus 36 degrees. 180 degrees minus 36 gives us 144. So 2x is equal to 144 degrees. Now to get x by itself, let's divide both sides by 2. 2x divided by 2 gives us x, which is equal to 144 degrees divided by 2, which is 72 degrees. X is 72 degrees, but we know that y is equal to x, which means that y is also 72 degrees. Let's do another one. Find the value of x. Now we know that the square angle at D up here shows us this is a 90-degree angle. So let's put 90 degrees in here. We know the sum of the interior angles of a triangle is 180 degrees. So let's add these up. We say x plus 65 degrees plus 90 degrees gives us a total of 180 degrees. Now we can simplify. We have x, 65 plus 90 gives us 155. So we say plus 155 degrees is equal to 180 degrees. And now we can solve for x. So let's leave x on the left, make this equal to, we're going to move 155 to the right. So we say 180 degrees minus 155 degrees, which means that x is equal to 25 degrees. Let's do another example. Find the value of x. Here we see that angle G is x and angle I is 3x, and we don't have a value for angle H. But the small blue line over here and over here tells us that side GI is equal to side HI. So this is an isosceles triangle with two equal sides and two equal angles. Angle G lies directly opposite side IH, and angle H lies directly opposite side GI. GI and HI have the same length, which means that angle H must be the same size as angle G, which we've been told to be x. So let's tidy this up, and we can fill an x into our diagram at angle H. Now we can add up our interior angles. So we have x plus x for angle H plus 3x for angle I. And we know this will be equal to 180 degrees. Now on the left, x plus x gives us 2x plus 3x gives us 5x, which is equal to 180 degrees. To get x by itself, let's divide both sides by 5. On the left, we now have x, which is equal to 180 degrees divided by 5, which gives us 36 degrees. Let's do another one. Consider the triangle and answer the questions. A, determine the value of x, and B, classify the triangle. Let's start with part A, determine the value of x. Now, angle J is drawn as a square angle, so we know that this is 90 degrees. So let's put 90 degrees into the diagram. We know the sum of the interior angles of a triangle is always 180 degrees. So let's add our angles together. We have the 90 up here, so we say 90 degrees. Then we have x plus 15, so we say plus x plus 15 degrees. Angle L is 2x, so we say plus 2x, and we make this equal to 180 degrees. Now we can add like terms. 90 degrees plus 15 degrees gives us 105 degrees. X plus 2x gives us 3x, so we say plus 3x, which is equal to 180 degrees. To get the x term by itself, let's move 105 to the right. So on the left, we now have 3x, which is equal to 180 degrees minus 105 degrees. 3x is now equal to 180 minus 105, which is 75 degrees. To get x by itself, let's divide both sides by 3, and we see that x is equal to 25 degrees. Now we can move on to part B, classify the triangle. We know that angle J is 90 degrees, so let's put this back into the triangle. This angle tells us that we are working with a right-angled triangle, but is it scalene or is it isosceles? We haven't been given any sides to work with, so we need to look at the other two interior angles. We've just found that x is 25 degrees, so let's make a note of this as well. Angle J is 90 degrees, so we can make a note of this down here as well. Now we need to find the value of angle K. So we can say angle K is equal to x plus 15 degrees. We know that x is 25 degrees, so we can say 25 degrees plus 15 degrees, which gives us 40 degrees. Now we can move on to angle L. We can see that angle L is equal to 2x. X is 25 degrees, which means that L is equal to 2 multiplied by 25 degrees, which means that L is equal to 50 degrees. All three angles are different. This tells us that all three sides are different as well, which means that this is a right-angled scalene triangle. Let's do one more example. Consider the triangle and solve for x. Here, angle O is the exterior angle, and angles M and P are the opposite interior angles. And we know that the exterior angle is equal to the sum of the opposite interior angles of a triangle. And we can use this idea to solve for x. The exterior angle, 4x plus 10 degrees, so we can say 4x plus 10 degrees is equal to the opposite interior angles. M is 2x, you can say 2x, plus P, x plus 40. So we say x plus 40 degrees. On the left, we now have 4x plus 10 is equal to, let's add like terms on the right. 2x plus x gives us 3x plus 40 degrees. Now let's put our x terms on the left-hand side. So we have 4x. Let's move 3x across. We get minus 3x is equal to, on the right, we already have 40 degrees. Let's move this 10 across. So we say minus 10. 4x minus 3x leaves us with x, which is equal to 40 minus 10, which is 30 degrees. And we have now completed this question.